friends. You're watching my YouTube channel Littlentist Bhanda, and today I want to continue on my ISRO mission, in which mission I told you about the space and the brief history of ISRO. Now, you might be wondering, how do rocket actually work? But to learn that, we have to learn from basics. So today, I will tell you what are orbits. What is orbit exactly? Orbit is a part of an object that goes around another body. So, like an example, we have a sun. We have our sun over here. Then we have our earth. So, earth moves around the sun in a circular path. So, that is called a orbit. So, what does a orbit make it work? So exactly, sun is applying gravitational force on earth. So earth want to go this way, but sun's gravity pulls the earth in this way. So they counteract each other and create centrifugal force that makes earth go and turn around the sun in an orbit. So, to create an orbit, we need speed, gravity, and two objects with mass. So, let's say, no, for example, our Earth has a speed of 30 km per second and it goes around the sun. See, if sun doesn't have any gravity, Earth will just go into outer space. But sun's gravity pulls the earth back, and now earth want to go this way, but the sun's gravity will pull this way, and now earth will go this way, but sun's gravity will keep it from going away. So now what happened? It will go in a circular path around the sun. It tries to go out of the sun's orbit, and the sun's gravity tries to pull it in. So what happens? Because of the speed and the gravitational force of the sun, the earth starts to orbit the sun. Now, there are various types of orbit. What are the types of orbit? The types of orbit are low earth orbit, medium earth orbit, and geocentric earth orbit. So now, let's go to low earth orbit, or LEO. The low Earth orbit ranges from 160 km to 2000 km. Now let's recap what I've told you. In the previous video, I've told you that space starts from the Kármán line, that is at 100 km. And the low Earth orbit starts. This is the Kármán line, and after 60 kilometers starts the low Earth orbit. And then it goes above to 2000 kilometers. Now in this area the satellites are moving. So when satellite moves this between 160 and 2000 kilometers, it is said to be the satellite is in low earth orbit. The orbital period of the satellite is nearly 88 minutes to 127 minutes. So now what is orbital period? Orbital period is time taken to orbit. So let's imagine this is my earth, this is earth, and this is the low earth orbit, and this is satellite. It takes 18 minutes to the satellite to complete one rotation. So the orbital time, the time taken by the satellite to rotate among the earth is 88 minutes, and that is what is orbital period. So don't be confused, it is very simple. Now the speed of satellite is nearly 7.8 km per second. So why so much fast? The reason is because you're very close to earth, only under 2000 kilometers. So the satellites need to move very fast. So see exactly what is happening. This is the earth, this is the satellite. The satellite will fall because of the gravity. When it's launched, it will fall down. But the speed is so high that when it's falling down, it will get past the land. When again, so why the speed need to be so high? The answer is, but I have to give an example first. So let's take the ball as the earth and this pen cap as the rocket. As this pen cap gets launched, it will start to fall down because of gravity. So we do example, we will try to make it even faster. It goes still falls down. Let's go even faster. Zzz. Let's go even faster now. This is going really fast. Bzzz. See what happened? The Earth's gravity was not able to pull the rocket down. So, what was the speed exactly of our rocket? And that was 7.8 kilometers per second. Yes, that is how much speed we need to get into low Earth orbit. Now, let's go to medium Earth orbit. Medium Earth orbit ranges from 2000 kilometers to 35,785 kilometers. Yes, you heard it right. 2000 kilometers to 35,785 kilometers. That's a very big difference. So, now let's get into it. Now, when a satellite range between 2000 and 35,780 kilometers, it is said to be in medium Earth orbit or MEO. So, what is the orbital period of the medium Earth orbit? The orbital period is 2 to 24 hours. That's a big number or time for to orbit the Earth. The speed of the object is surprisingly 3.14 kilometers per second. Why? Why so much less speed? Let's go to example. I will take my globe again. So now, in low Earth orbit, this much was the area to be in the low Earth orbit. So this much. So now, what happens? The rocket does not have enough space to get. So rocket needs to move even faster at 7.8 km per second. But in medium Earth orbit, the satellite has this much space to move. So even if it is going at 3.14 kilometers, it is enough to go into orbit. So that is a huge difference between the low Earth orbit and the medium. Now let's go into the biggest orbit, the geocentric orbit. Now what is the geocentric orbit exactly? The geocentric orbit is the orbit that is above equator, exactly above equator and near 35,785 kilometers. So what are the criteria to be in geocentric orbit? It should be exactly above the equator. So example, this is the equator. My satellite is above this much. It is directly above the equator and rotating directly above the equator. It will never be over here or here. It will always be above the equator at 0 latitude. Now, the height or the altitude of the rocket should be near 35,000, that is over here, 35,780 kilometers. So, satellite needs to be around 35,585 kilometers. Now, these are the requirements to be in geocentric orbit. Now, there are more orbits like the polar orbit and the sun synchronized orbit or SSO. And I want to tell you more. The short form of geocentric orbit is GEO. So now, what are polar orbits? Polar orbits are the orbits that go over the polar region. For example, I will take my globe again, our Jugadu globe. I went down. See, our Jugad rocket is here. So our rocket launches. The ISRO NASA V launches. Then it is goes up and orbits. And don't forget, this is the north pole of the globe. It goes and it directly goes above the poles or the north pole, and then it turns and goes above the south pole. So it rotating vertically, rotating in longitudinal terms. So it rotates vertically to the equator. So this is equator, this is the equator. The rocket will go this way. It will not go this way, it will go this way. Now, what is sun synchronized orbits? So, for example, I need someone. I'll just keep it here. And this is my sun. Then this is the south pole. And this is the solar panel or the face of the rocket. This is the facing. Now this side is always facing towards sun. Always facing towards sun. Always facing towards sun. So I will put this Zugaru away. So this side is facing the sun. You can see it turns to be constantly facing earth. Even if it's behind, this is earth and this is over here is sun, it will still be facing the sun. Then it go up and again the cycle continues. Now comes the transfer orbit, the fifth part of orbits. So what is now transfer orbits? Transfer orbits are the orbits that we are able to transfer from one orbit to another orbit. For example, this is our Earth and this is Chandrayaan 3. Chandrayaan 3 launches, it goes into a transfer orbit and transfers to Moon's orbit. So now, this is a transfer orbit. Now what is geostationary transfer orbit? In geostationary transfer orbit or GTO, there are an elliptical orbit. Now what is elliptical orbit? You have heard shape oval. There is something called an oval shape, and that is ellipse. There are different types of ovals. Some are really long, some are really squished. There are types of ovals. Now, in geostationary orbits, the elliptical orbit is long. It is very long. So see, the orbit is something like this. See our rocket. It goes and goes up here, very high. It comes down like this. This is like an oval shape or an egg shape. See, to be a geostationary transfer orbit is the long part. You see that? See, this is Earth. This is where the rocket is closest to the Earth. We call this apoapsis. This is the apoapsis state. Then it goes. This is the longest the rocket will be from the Earth. So this is called apoapsis. The rocket's apoapsis should be 35,780 kilometers. Then it will be in a transfer geostationary orbit or GTO. So these are the types of orbit you will mainly see in rocket science. And now the question lies, how does rocket work? For that, I'm not going to say it right now, but I will give a hint. This is a cylinder in which fuel is added and combustion happens in the cylinder. So if you want to learn more, okay, this will come into my next video about rocket science. Jai Hind, Jai Bye Bye. Very good, ISRO.